Hello there. In this problem we are computing the definite integral of the square root of 81 minus x squared. When you see this problem, you might think that this square root of this quadratic term might make you think of the Pythagorean theorem, because the lengths of the triangles in a right triangle, the length of the edges in the right triangle can be given as square roots of the quadratics just coming from a squared plus b squared equals c squared. What the Pythagorean theorem is really expressed in terms of trigonometry as the Pythagorean trig identities. Now, the basic one is sine squared theta plus cosine squared theta equals 1. And here we get three different forms of the same equation, that one of which will be used to solve this problem. So if we take this mother identity and divide by, what do we divide by? We just subtract sine to get this blue identity. Now, there's another one that we can get if we just divide by cosine. So in that case, we get tangent squared plus 1 equals secant squared. And then if we just take this red guy and subtract 1, we get tangent squared is equal to secant squared theta minus 1. So we have blue, red, and green. Each of these are really the same Pythagorean trig identity in its own unique form. One of these is going to be substituted in for this 81 minus x squared. Now, to figure out which one we use, we need to do a little algebra on this 81 minus x squared. So let's take 81 minus x squared, and let's just factor out this 81. Then we're left with 1 minus x squared over 81. And then you might imagine this x squared over 81 as being x over 9 quantity squared. Now you're thinking, okay, which one of these trig identities most closely resembles this expression in pink? Well, it's this guy, right? So we have 1. The 1 matches up with the 1. There's a minus, minus. You just recognize the pattern. Well, so if we set x over 9 equal to sine of theta, then that tells us that x is 9 sine theta, and then dx will be 9 cosine theta. Okay, very good. And so this expression now equals 81 times 1 minus sine squared theta. So we can substitute this green portion in for 81, 1 minus sine squared theta, and our dx is 9 cosine theta. So let's do that next. So our integral is written as the square root of 81 times 1 minus sine squared theta times 9 cosine theta. Now the bounds of integration have changed because we're integrating with respect to theta. So let's figure those out really quickly. When x is equal to 0, that means sine of theta is equal to 0. Sine is equal to 0 at 0. When x is equal to 9 root 3 over 2, well, that means 9 sine theta is equal to that, and so we cancel the 9's, whereas sine equal to root 3 over 2, and that's at pi over 3. So the bounds of integration, the limits of integration, are 0 and pi over 3. Okay, now the reason we did all of this is because of this cosine squared here, because this expression now equals cosine squared. And so we have the square root of 81 times cosine squared theta, 9 cosine theta, that's a d theta, and I should have had that d theta there. Well, The square root of a product is the product of the square roots, and so we can split these into two square roots. The square root of 81 is 9, and this 9 will come out in front, but this is also a 9 here, and so this 9 will be multiplied by the first, and we'll have 81 out in front, 0 pi over 3. The square root of cosine squared is cosine, but then that's this cosine, and this cosine has to be multiplied by it as well, and so here we have cosine squared d theta. We're not worrying about whether or not the square root is positive or negative, because our theta is in the first quadrant here. Okay, very good. So now we've greatly simplified the problem. We have arrived at the computing this definite integral of cosine squared. This can easily be done using the half angle formula. Okay, so this is now 81 times the integral from pi over 3. Now, cosine squared is 1/2, maybe it's the double angle formula, I'm sorry, 1/2 times 1 plus cosine 2 theta. So the angle doubles. There we go. And this is d theta. So now we just need to integrate this guy. Okay, so continuing, we have 81. Now let's actually perform the integration. So 81 over 2. Now we're integrating this 1 with respect to theta, so we have theta. And then the 81 over 2 gets multiplied by the integral of this cosine. So let's just take that extra step. So this gets evaluated from 0 to pi over 3, and here we're still integrating from 0 to pi over 3. And so this is cosine 2 theta d theta. It's not quite in the form cosine u du. If we put a 2 here, we can compensate for that by dividing by 2. Now it's in the form cosine u du. And we have 81 over 2 theta plus 81 over 4. And the integral of cosine 2u is sine 2u. And we're evaluating that from 0 to pi over 3. If we substitute pi over 3 in, we'll have 81 pi over 6 plus 81 over 4 times sine of 2 pi over 3, and sine of 2 pi over 3 is, that's pi over 3. Sine of pi, excuse me. And sine of 2 pi over 3 is the square root of 3 over 2. And then when we substitute 0 in, we get 0, and sine of 0 is 0. So this is our final answer for time. All right, have a good day.